पे हमने क्या चीज़ बस ये this is the last one, I think so. We made this understanding, right? So now we have to make this understanding what it is. So parameters क्या होते हैं असल में, वो हमने समझ लिए थे। ये फैक्टर्स जो है होते हैं। तो यहाँ पे अगर मैं अपनी डेफिनेशन यहाँ पे लिखना चाहूँ तो व्हाट इज़ पैरामीटर। ओके, एआई मॉडल्स क्या होते हैं हमने बात कर ली थी, और उसमें जो पैरामीटर्स होते हैं, ओके, व्हाट आर द parameters. I can see that uh, parameters equals to, what are they? Parameters are the um, here they explain parameter is a number the model learned on its own during the training that controls how it make decisions. So parameters ये होते हैं। A parameter is a number the model learned on its own during the how it looks like, how it looks like. So it just looks like this one. And when there is something like this, so here we can have it like this one, www and bb. So these are the parameters, what the the parameters equals to weights plus bias. And what is weight? Weight equals to the weightage, influence it gives to the input parameters. ओके, सो पैरामीटर्स जो है ये होते हैं वेट्स इक्वल्स टू दिस वन, weight equals to this one, and bias equals to starting point of calculation. ठीक है, so yep, ये आ जाते हैं how it looks like. We have if we have something like this, suppose we have a model, we have a spam filter model with one neuron. Okay, neuron have the neuron is the function that calculate with the calculate the result with the weights and bias. Okay, so like this one, so this is like this, here it is, factor 1, factor 2, factor 3, this one like this one, bias. Okay, neuron equals to this one. So here we go, here we have, if we have the spam filter, spam spam model. If we have this spam model, then we can say that if there are 5 of this, and 0 sender, then it is going to be calculate this thing in this way. तो यहाँ पे इसने जैसे कि स्पैम है, तो यहाँ पे बॉर्डर लाइन में आ गया है ये 445, तो यहाँ पे इसका स्पैम का स्कोर ये आ गया है। तो अच्छा, यहाँ पे एक चीज़ कंफ्यूज कर रही है मुझे, ये जो स्कोर है ये उन्होंने कैसे निकाला था, बट ये है कि ये जो आपका वेट्स हैं यहाँ पे ये आ गए हैं। अब मुझे ज़रा सा इसको स्पीड अप करना चाहिए, न्यूरॉन्स को और यहाँ पे स्पैम को। तो लेट मी आस्क वन थिंग, how this final score calculated. Okay, right. Final score calculated. Okay. अच्छा, यहाँ पे जो इन्होंने बोला है फाइनल स्कोर का कैलकुलेट करने का, एग्जैक्टली द सेम 3 रूल्स जस्ट अप्लाई टू द स्केल। ओके, नहीं यहाँ पे नहीं, ये नहीं है, यहाँ मैंने से पूछा, इसका जवाब आ गया है। सो यहाँ पे है 4 इंटू दिस वन, सही है, ये इसका आ गया एड बाय एस द मॉडल स्टार्टिंग पॉइंट विच इज आई थिंक नॉट दिस। ओके, बायस यहाँ पे उन्होंने वाज़ेह नहीं लिखा हुआ। सो जो इसका बायस है, ओके, हियर इज एग्जैक्टली इसमें यहाँ पे इसका बायस 5 है, ठीक है, ये 5 इसका बायस है। सो दिस इज़ व्हाट इट इज़, सिंस इट फॉल्स बिटवीन 3 into 6.5 द मॉडल इज अनसर्टेन, ठीक है ना। तो ये जो 6.5 आया ये इसका बायस आया है, क्योंकि यहाँ पे ये इन्होंने लिखा हुआ नहीं है। सो दैट्स व्हाई इट इज़। सो मैं यहाँ पे सिर्फ और सिर्फ यहाँ पे कर देता हूँ। तो अगर मैं इसको पैरामीटर क्या होता है, सबसे पहले ये आएगा सवाल कि व्हाट इज़ द एक्चुअल पैरामीटर मीन्स, इज़ अ नंबर learn a model learn on its own during training that controls and how it makes a decision। तो यहाँ पे confusion तो है मुझे भी, वो यही है कि how can I explain you about this thing after all of these things I discover, but I'm also struggling to make it short as well and also make it understandable। I think so this is what it is। यहाँ पे ये अगर मैं इसको सिंपल सा लेके चलूँ तो आई थिंक सही होगा। हाउ मच इम्पोर्टेंट ईच इनपुट फैक्टर इज, डिफाइन द स्टार्टिंग पॉइंट पैरामीटर्स AI learned from the past data and set them in itself, okay, to define which factor have how much influence on the result yes, and what is the starting point, it is the starting point of calculation। Wait, for example, I think so this is enough। We have to we have to calculate the time. For example, if we give this thing, so there are the following things: partial weather and all of these things. Okay, so AI got the past successful delivery data as follows. Okay, and then now, for example, now the model see these factors distance and learn the pattern that when this specific distance. Okay, अब यहाँ पे जो इसके पास डेटा आया है उसने ये यहाँ से सीखा है कि यार इस इन तीन फैक्टर्स का, ये चार फैक्टर जब इस तरीके से होते हैं तो ये आता है इसका आपका एक्चुअल टाइम, और अगर इस तरीके से होते हैं तो ये आता है। तो वो डिफरेंट उसने यहाँ पे डेटा को समझ के किया। अच्छा यार, अगर इस तरीके से ओवरऑल इसके जो है ये रिजल्ट्स होते हैं, यानी कि ये एक्चुअल डेटा है डिलीवरी का जो कि इसने देखा, जैसे कि हम लोग देखते हैं और उसके बाद हम समझना चाहिए अगर डिस्टेंस इतना हो, ट्रैफिक की ये कंडीशन हो, पार्सल इतने हो, तो और वेदर की ये कंडीशन हो, तो ओवरऑल जो है हमारा टाइम इतना लग गया। फिर उसके बाद जो है एक नेक्स्ट डिलीवरी हुई, उसमें ये चीज़ समझी उन्होंने कि अच्छा इतना डिस्टेंस था, इतना ट्रैफिक था, इतने पार्सल्स थे, इतना ये था और इतना लगा था टाइम। फिर ये थर्ड हुई डिलीवरी, एंड देन दैट्स हाउ इट कीप्स अंडरस्टैंडिंग ऑल ऑफ दीज कि अच्छा यार ये एक्चुअल डिलीवरीज हैं और यहाँ से इसने ये चीज़ सीखी है। ठीक है, अच्छा भाई, तो जब इसके पास ये डेटा आ गया तो इसने उससे को रिलेशन निकाल ली कि अच्छा यार जब इतना डिस्टेंस हो, इतना ट्रैफिक हो, इतने पार्सल्स हो, इतने वेदर हो, तो इधर जो है हमारे पास ये वेट इतना आता है टाइम। ठीक है, अब उसने यहाँ से देख के अपने अंदर जो है एक चीज़ को कर लिया सेट कि यार जब अगर डिस्टेंस का टाइम पर इतना इन्फ्लुएंस है, ट्रैफिक का डिलीवरी टाइम पे इतना इन्फ्लुएंस है, और पार्सल्स का इतना इन्फ्लुएंस है, और वेदर का इतना इन्फ्लुएंस है। ठीक है, अब ये जो इसने इन्फ्लुएंसिंग फैक्टर्स को जो अपने अंदर समाया है वो कहलाता है वेट। वो इसको एक देगा वेट कि यार इसका जो है इतना परसेंट असर है, इसका इतना परसेंट असर है, इसका इतना परसेंट असर है, इसका इतना परसेंट असर है। तो और फिर जो है उसके एतबार से ये आगे जो है वो अपने किस चीज़ को कितनी अहमियत देनी है वो चीज़ ने सेट कर ली। नाउ इट एडजस्टेड, इट हैज़ फोर फैक्टर्स टू कंसिडर व्हाइल मेकिंग द डिसीजन, then the AI put the weight with these factors as which of the following factor has this influence। ठीक है, तो अब यहाँ पे अगर हमने here's the weight or defining the influence of each factor on the total delivery time. And now here is the one more thing, that even if there is one person to deliver uh, bias। okay, so यहाँ पे now the model has received data and the covered the model to deliver how much, now it adjusts four things making the decision। okay, so इसके बाद जो है इसने ये चीज़ की from the data from the data AI said recognize how much influence the each factor have। ठीक है, each factor have। ठीक है, ये हो गया and set set it in the number form that is called weight। ठीक है, so okay, now it adjusted, it has four factors to consider while making decision, then the AI model put the weight with these factors as these factors is influencing how much total delivery time that has the 4 weights, so on. ठीक है, here's the way is defining the factor. So ये चीज़ आ गई. अब यहाँ पे जो है इसने बायस को किया सेट किया, यार इतना तो जो है टाइम इसमें लगेगा, इसमें ये चीज़ आ गई. Therefore the model has to consider the following things to make the decision. So what is the decision they have to make? Model has to make the decision. Therefore the model has to consider the following things to make the decision: weights and bias, minimum time regardless factors. 1 किलोमीटर इसने यानी कि मैंने एक अंदाज़न जो है ये चीज़ इसमें समझाने के लिए बता दी कि ये चीज़ है. So I think so when I'm going to make an article of it, let's try to make this article with the help of AI. Okay, so now what I can do is that क्योंकि मुझे लंबी लग रही है example, but and I think that people might unable to understand it well. So यहाँ पे मैं एक काम करता हूँ. Let's try to make an article out of it. अगर ये हो जाता है कॉपी तो ठीक है, यहाँ पे नहीं हो रहा है. पेंट्स आ रहा है. Okay, so this is the diagram which we have, parameters diagram. Okay, yep, we can have it here. And one more thing, I have to make this thing in this way. So okay, requirement: make an article from it that is easy to understand. ठीक है, ये सारी मैंने अपनी अंडरस्टैंडिंग इसमें डाल दी है for the layman. ठीक है, and then let's have it from it. ये टॉपिक को ज़्यादा लंबा खींच गया, हालांकि इतना लंबा खींचना नहीं चाहिए था. ये बस मुझे ये हो रहा है कि इफ़ यू गाइज आर अनएबल टू अंडरस्टैंड और नॉट एबल टू अंडरस्टैंड और नॉट, इसमें पैरामीटर्स बहुत अहम चीज़ है जिसको हमें लाजमी तौर पे समझना चाहिए कि ये होते क्या हैं. और फिर हम जब किसी भी ए मॉडल के ऊपर काम करेंगे तो उसमें हमें समझ में आ जाएगा कि हाँ, कि ये मॉडल हमारे यूज़ केस के लिए है भी या नहीं है. ठीक है ना. सो दैट्स वाई ये अभी कैलकुलेशंस ही कर रहा है. और लेट्स वेट एंड सी फ्रॉम इट. अच्छा जी, इसने ये आर्टिकल यहाँ पे लिख दिया है और ये बड़ी लंबा लिखा है इसमें ना. It will be hard to understand. You have probably heard the Gemini has over is a trillion. It sounds impressive, it sounds huge, but what's a parameter actually? Here's the definite a symbol. A parameter is just a number, that's it. A trillion parameters means trillion numbers sitting inside model quietly doing one helping to make the decision. Let's unpack what their job did. Parameters: every parameter in an AI model falls into one of two buckets. How much influence a factor has on the result, the starting point of the calculation before any factors are even considered. That's the whole idea. Once you understand these two things, you understand what a parameter is, whether the model has 5 of them or 1 trillion. A real example: predicting delivery time. Let's say we want an AI model to predict how long a delivery how long a delivery will take, we give it four factors to consider: distance, traffic, weather, number of parcel. The AI, okay, जो इसमें जो AI होता है is trained to thousands of delivery pass डिलीवरी डेटा। जैसे कि यहाँ पे आपको मैंने दिखाया था कि यहाँ पे ये ओवरऑल यहाँ पे डेटा है इसका, और यहाँ पे जो हमने इसको ट्रेन कराया पास डिलीवरी की डेटा से, उसने फिर उसके दी आई ट्रेन ऑन थाउजेंड्स ऑफ पार्स डिलीवरी, ईच वन ऑफ दीज four factors recorded along with how long the delivery actually took. From this history, the model learns a pattern: when distance is this much, traffic is this bad, weather is this thing, and there are this many parcel, delivery tends to take this long. But here is the key insight: not all four factors matter equally. Distance might be a huge factor, numbers of parcel might uh, matter a little less. Okay, yep. Distance can be a huge factor, but जो number of parcels हैं, क्योंकि अगर उसकी 30 पार्सल को डिलीवर करना है उसको, तो वो अगर उसको 10 पार्सल में 1 मिनट लग रहा है, तो उसको यानी कि 10 पार्सल उतारने में अगर उसको 10 मिनट लग रहे हैं, या उसको 5 मिनट लग रहे हैं, तो उसको 20 उतारने में 5 मिनट और लगेंगे या उससे भी कम लगेंगे. So here's how the parcel influence is: the model needs a way to capture how much factor matters, and that's exactly what a weight is. So the model assigns each factor its own weight. Distance, this is this, but wait, what about the minimum time? Even if the is just one parcel one block away, perfect weather, zero traffic, it still wouldn't take zero time. The driver has to load and unload, drive, park, and hand it over. There is on a minimum unavoidable time backed in. Okay, so ये जो हमारे पास क्या है, that's the minimum. That minimum is the bias. In our example, let's say that baseline is 10 minutes, about 0.1 of an hour. Okay, so the bias doesn't depend on any factor, it's just there always. It's the model starting point, the number it begins with before it even looks at distance or these things. Okay, क्योंकि कम से कम इतना वक्त तो लगना ही है, इसलिए जो है ये इसमें bias आता है. Putting it all together, here's the formula the model uses: total time in this one. Now let's plug in the real number for a delivery, and then calculation going to be this one. The model predicts delivery 10 hours, 0.46. Wait, I see four factors, so shouldn't be there four parameters. Get question, look closely at what actually we used. Okay, four weights, one for each factor plus bias, that's five numbers total, and every single one of them is a parameter. Okay, so the bias is also a parameter. The bias is easy to forget because it doesn't belong to any factor, but it's just as learned number as the weights are, and it counts towards the total. So where does 1 trillion come from? Here, here, here's the here's the part that makes everything click. A model, a model like Gemini, GPT-4 uses the exact same idea, just as a massive scale. Instead of a factor, it considers thousands of factors at once. For language model, these factors are related to words, context, and meaning. And instead of one single calculation, it repeats this weight bias process across hundreds of layers, each one feeding into the next. So instead of this ones, you get something like thousands of weight plus thousands of biases into repeated across hundreds of layers over 1 trillion parameters. Same idea, same formula, just repeated in normal scale. The one sentence parameter is a number the model learned from its own past data. It tells the model either how much a factor matters, or or where to start before considering anything bias. One truly parameter isn't doing anything mysterious, it's just doing the same weight bias math a trillion times over, okay, across a network so deep that it can capture the patterns of human language, images, and more. The math is simple, the scale is staggering. So that's it. That's all math in the end. That's all math in the end. Okay. So now we have, this is a good article, I think so, and yep, I think so. It's a good article overall. Let's try to have it. Let's try to have it. Uh, let's see if we can have it here with this understanding. Are we able to get it? हाँ, यहाँ पे टेबल तो मुझे लगा था ख़राब होगा 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 ही होगा 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 यहाँ पे टेबल यहाँ पे आ रहा है distance and this staggering. Okay, yeah, मैं इसको इस तरीके से बना दूंगा, फिर ना इस तरीके से कर दूंगा. So we can have it in this way, minimum distance and this one. So if I'm going to make a diagram out of it, then it would be good. And I think so if I make a diagram out of it, then it would be good. और diagram किस तरीके से हो सकती है, we can have it here. Okay, so delivery diagram, right? So we can have this factor here. Okay, this is a good one. This is a good one. And delivery, right? And here's the delivery part. If we got the diagram of it, the delivery one, then it's good. If not, then we can make it. So यहाँ पे हम इसको इस तरीके की डायग्राम बना लेते हैं जो कि हमने यहाँ पे बनाई है, ठीक है. So let's have it here. अगर मुझे यहाँ से इधर डिलीवरी करनी है एक कार की, okay, there's a car. कार कैसे बनाएंगे यार, कार ऐसे बनाएंगे, कार ऐसे बनाएंगे क्या? Okay, so कार की तो मेरी हालत करी हुई है. Okay, so here's a car. Can have it. Okay. Here's a delivery. Here's his delivery spot. You can say that this is the delivery spot. We have it. You can say it is a car, okay, or a car. You can say cargo. It is a cargo. अबे यार, cargo, ठीक है. ये आ गया इधर, और यहाँ पे आ गया हमारे पास delivery spot. और यहाँ पे हमारे पास इसका डिस्टेंस आ गया, डिस्टेंस आ गया हमारे पास यहाँ पे कि यार इतना डिस्टेंस यहाँ पे इधर लग रहा है. सो यहाँ पे डिस्टेंस हमारे पास आ गया, हमने बोला कि 10, हमने कितना बोला था, 10 किलोमीटर, 10 किलोमीटर, राइट? I think so in our example it is around 10 kilometer or what? In our example here it is, अरे यार ये कहाँ खोलेगा ये, छोड़ यार, तो नहीं खोल। यहाँ पे ये आ गया है, हमने बोला कि 10 किलोमीटर का डिस्टेंस है। ट्रैफिक जो है हमारे पास, ट्रैफिक जो है वो हमारे पास आ गया अराउंड 2/10 का, ठीक है। ओके, ट्रैफिक हमारे पास आ गया ये 2/10 का। और वेदर जो है हमारे पास आ गया इतना, वेदर हमारे पास आ गया ये, वेदर हम बोल रहे हैं कि हमारे पास ये आ गया 10/10, और इसके साथ जो हमारे पास ये आ गया, पार्सल्स आ गए हैं हमारे पास, हमने ये आ गए हैं, पार्सल आ गए 30, ठीक है। 30 पार्सल इसको डिलीवर करने हैं, इधर डिलीवरी स्पॉट है यहाँ पे, यहाँ से। सो अब जो है इसको कितना टाइम लग सकता है, सो इसमें क्या होगा, इसमें आपका जो है यहाँ पे 1 2 3 4 है, यहाँ पे आपका आ जाएगा डिस्टेंस, डिस्टेंस इक्वल्स टू दिस, equals to this, okay, distance equals to this, भाई यार चलना, यहाँ पे आ गया डिस्टेंस, ये आ गया, ठीक है। अब यहाँ पे इसको कैलकुलेट करना है, तो मॉडल में यहाँ पे जाएंगे, हमारे पास कितने, एक जाएगा, दूसरा जाएगा, दूसरा इनपुट जाएगा, तीसरा इनपुट जाएगा, और फिर ये जो है you can do this in this way, ये आ गया। फिर इसके बाद जो है ये इधर हमारे पास कैलकुलेशन होगी इस न्यूरॉन में, इधर कैलकुलेशन होगी, और फिर ये न्यूरॉन हमें एक रिजल्ट दे देगा, इधर, ठीक है। अब ये वाला जो न्यूरॉन है, मैं इसको चाहूँ तो इसको थोड़ा सा बड़ा कर देता हूँ, ताकि इट विल हेल्प टू मेक द कैलकुलेशन इजी, राइट। और फिर यहाँ पे उनके पास ये जो न्यूरॉन है, इसको मैं थोड़ा सा बड़ा कर देता हूँ, ताकि आ जाए कि ये आ गया, और यहाँ पे इसको लेट मी मेक इट अंडरस्टैंडेबल, ओके गाइस, ओके, ये आ गया। अब यहाँ पे बोलूँगा डिस्टेंस आ जाएगा यहाँ पे, ठीक है, और यहाँ पे आ जाएगा वेट, यहाँ पे आ जाएगा वेदर, यहाँ पे आ जाएंगे पार्सल्स, और फिर ये यहाँ पे इस तरीके से जाएगा, एक यहाँ पे गया, ओके, ये इसको ऐसे करते हैं, एक यहाँ पे गया, फिर ये एक वेट यहाँ पे गया, इसका वेट यहाँ पे गया, और इसका ये इधर ही गया। ठीक है, अब अगर मैं चाहूँ तो इसको यहाँ पे लिख देता हूँ कि वेट इक्वल्स टू, हमने कितना किया था यहाँ पे, जो इसने सीखा था डिस्टेंस का सीखा था इसने, दिस वन, ओके, एंड वेट equals to 0.2, ठीक है। और फिर उसके बाद जिसका वेट था वेदर का 0.3, और फिर इसका जो वेट था वो था इसका W equals to 0.2, ठीक है। सो इसके डिफरेंट वेट्स आ गए इधर, और यहाँ पे ये जाके ऐसे कैलकुलेशन इसकी हो जाएगी। अब यहाँ पे जो कैलकुलेशन है यहाँ पे इसकी इस तरीके से होगी, ठीक है भाई। एंड यहाँ पे इसके पास बायस जो था इसका B equals to, अच्छा यहाँ पे इसका जो बायस था वो था हमारे पास 0.16, सो यहाँ पे ये था इसका, और उसके बाद जो है वो हमारे पास जो टोटल टाइम आएगा, टोटल टाइम यहाँ पे हमारे पास जो कैलकुलेशन होगी वो इस तरीके से होगी, छोटा पड़ गया ये, ओके, चलो इसको मैं रिमूव करता हूँ ताकि अंडरस्टैंडिंग आसान हो जाए। और यहाँ पे आ जाते हैं हम ये, I think so this is good enough, it is good, and okay, थोड़ा सा रंगा हो गया ये। So here we go, here we have this one, here we have B equals to 0.16, यहाँ पे ये आ गया 16, ठीक है। अब यहाँ पे टोटल डिलीवरी टाइम जो है इसका हमारे पास ये आ गया, that's how it is calculating, okay। अगर मैं इसका I think so this is well enough, this is good enough, right? ठीक है ना। So and then there's the calculation we are going to do here. Total time equals to this one. Oh my gosh. equals to total time हमारे पास ही आ गया ठीक है so and then what is going to be and then this output is going to be this one right यहाँ पे ये आ गया और यहाँ पे हम थोड़ा इसको इधर कर देते हैं थोड़ा डिस्टेंस हो जाए and then you have this one right this here so यहाँ पे थोड़ा सा अगर नीचे करो इसको ओके यहाँ पे आएगा ये इनपुट लेयर जो कि हमारे पास इस तरीके से करके आ जाएगी this way इनपुट लेयर आ गई ये इसकी हिडन लेयर आ गई हिडन लेयर आ गई इसकी ये ओके और इसको हम बोल देते हैं न्यूरॉन and then this is the output layer okay so आगे इसकी output layer आ गई so यहाँ पे इसकी output layer आ गई so that's how these are the layers are there and then this is simple type of calculation happening here so right this is what the parameters are a number of parameters equals to weights plus bias okay so यहाँ पे ये आ गया equals to 4 weights and there is one bias total 4 no not 4 there are 5 parameters यहाँ पे simple सा ही आ गया ठीक है that's how it is there are number of parameters कितने 5 parameters यहाँ पे think so that is enough and parameters explained चलो parameters explained ठीक है AI parameters explained so let's go and let's see my understanding go let's see what the AI would say about our understanding it is right or not got it. Okay, so this is actually, it is generally a strong teaching diagram. A few things you got exactly right. The structure works completely. Okay, yeah, go. And let's so the structure works completely. Complete the story. Yeah, okay. The top cargo delivery is positive for parameters at the library scenario. The bottom half input layer translation the same scenario where even someone can follow the journey of the real delivery as the internal math without losing the thread. There's hard part and you nailed it. The neuron as container idea is clever. Uh, putting the formula inside the neuron circuit with the bias label at the top of it visually reinforce that the bias lives inside the neuron itself, not as a separate. There is a subtle point that's easy to get wrong, and your layout makes intuitive without needing extra explanation. Calculation is fully correct, matches exactly. Parameters in 5 parameter is perfect. One takeaway, one small suggestion: if you want it to push further the general audience, the red color is used for both the weights and the full formula text inside the neuron visually feel like the same category, even though though one is a learned number and the other one is the calculation part. If you wanted extra layer of clarity, you could color and the whites one shade with the bias, another one the echoing to the distinction, but honestly the version is clear enough to pushing the handwriting, so it keeps it approachable, which fits your authenticity over polish principle perfectly. Want me to generalize? uh, okay, let's okay, so I did it right. So this one is this. So now I think so we just done it. We just done it. Okay, so we just done it. Okay, so I think that that's good enough, and we can put it in this diagram. Okay, So yep, that's the key. And I think so that's fine as well. And for the weight part we can do, okay, yeah. So I think so it is all good, it is all good as per the understanding of the formula which we have till now. Okay, um, just wait. Okay, what happened, what happened now? Is it not working? Okay, so I think so we got it very good and we make it very well. Instead of doing the over polishing and all of these things, we can let's publish it now. Okay, let's try to publish it now. Okay. mm, let's try to publish it. And okay, we got it, we got it. And let's see why what we are going to do. Okay, here's the part. It says this is one thing which we can do, one thing we can do in this way. 14, 15. Okay, I think so it is fine. This is more polished version, we can say that. Hidden layer, neuron, neuron, hidden layer, and it is all of this good. Okay, we got it. It explains. So now we just done it, and we have to go and make it publish. So yep, so we done this part as well, which I think it is the hard part as well, but I think so we done it. Now we have to resume our next session, next topic, which will be the other one. I am looking to for the fundamentals. Okay, AI, this one, thinking done. Yes, this one. Okay, so how, what is AI model, how training works. So now let me ask, um what topics we have covered from your suggested topics. Okay, so it's going to be hard at first, but what we can do. mm, okay, so snapshot. Phase 1 is nearly done. Phase 2 well underway with deep detour into the math behind neurons, plus most of the phase 4 8 of us already explored ahead of schedule. Okay, foundation, how machines work. So neuron definition, how training, neuron definition, parameter bias. Okay, how training part, loss function, and this one is remaining. Okay, what, I also did it. Overfitting and generalization touched on. Attention mechanism, how along the words, tokenize image generation, prompt, and this one. Bonus tab beyond the original memo triggered by your own question. We went deeper into the matter underneath every model classification, the weighted formula, some parameters for layer activation function, below and why they prevent layers from collapsing. This is genuinely phase 2 plus phase maybe a stronger mental model of mechanisms than the roadmap order would normally produce. This easily, here's a full picture. You have jumped around the roadmap in a way actually makes sense. Instead of going phase by phase, you follow your curiosity. What's the model? Okay, yeah, the biggest gap started the phase 1, how training works. You understand what parameters are, what trained model looks like, but not how the model goes from random numbers to correct weights. There's the loss function plus gradient descent piece, and it would tie together everything you have already learned. Orange gap, and in regression you just see overfitting got a brief mention, but feature engineering, data processing, bias in data haven't touched how the trainings work. Okay, right. So yep, one more thing I just have to explain uh, explain me explain me what AI model built internally, the the parameters that we have not explicitly uh, provided, such as we provided for factors, but I think model produce its own correlations etc that generate various parameters on its own. So how it built and what they are, explain with example. Want to tackle how training was? It's a natural next step. Okay. Let's see what it is. Okay, got it. You're exactly right. This was the most powerful ideas in deep learning. The four factors you gave the model distance are the only inputs between the final answer. This creates an entire hidden layer on its own. New factors that it invented, made of combinations and correlations of original four. Nobody told it what these combinations should be. It discovered them during training because they help it predict delivery time more accurately. Okay, hidden layer, this one. Okay, I think it is making, or it is done. It is done. Okay, great. So the network, the hidden neuron to inspect what it learned. This one invented by training, hidden layer, as to possible meaning heavy long hold how load S2 carries almost entire about distance and parse it together, ignoring the traffic and the weather almost completely. It fires strongly only when both are high at once. A long trip carrying many parcel. This is a genuinely new factor, neither distance nor parcel alone, but their combination. A long trip with one parcel doesn't trigger it, neither does a short trip with 30 parcel, only both together. H1 possible. Okay, that's how it's work. Okay, okay. Possible meaning rush or congestion. H1. Okay, each neuron just gets the context. H or all its attention to traffic. 0.9 point 0.9 with a small nudge from weather. After training, this neuron fires strongly whenever traffic is heavy, regardless of how far the delivery is or how many parcels are on board. It has effectively become a dedicated. Is this a rush or delivery detector? Hmm. And the model never labeled it that way. This interpretation is our way of making sense of the pattern it found. Okay, heavy load, haul and uh, haul load. Okay, possible meaning bad weather shutdown. Bad weather is dominated with a secondary boost factor because bad weather often cause more traffic too. Okay, this neuron has discovered that weather and traffic are correlated and folds that relationship into a single combined uh, signal. This correlation the model found in the training data. Heavy rain days tend to also be high traffic days, and it captures both effects in one number. Possible mean quick local hope. Negative bets. Okay, negative bets on everything and large positive bias. Why? This neuron starts on by default bias 1.8 and gets switched off as any factor increases. It fires strongest when distance is short, traffic is light, weather is clear, and parcels are few. The easiest possible delivery. It acts how simple is this delivery detector, the inverse of all other neurons combined. Each hidden layer neuron is its own mini weights, some bias formula exactly like the one you already understand. It takes all four original inputs, multiplies each by its own learned weight, adds its own bias, and produce one number. That number represents how much does this particular pattern apply to this delivery. The model has 4 inputs, 4 hidden neurons, 16 weights plus 4 bias, 20 parameters just for this hidden layer. None of these 20 numbers were given to the model, all for discovered through training because together they let the hidden neurons act as four band, four brand new super factors that are more useful for predicting delivery time than the raw 4 inputs alone. The final neuron doesn't look at distance, traffic, weather, or parcels directly anymore. The final neuron doesn't. It only looks these factors, the 4 invented factors, and combines those 4 more weights, one bias to get final delivery time. Okay, this one. The final neuron, the output layer, combines the invented factors. The final neuron doesn't look at the distances, it combines these 4 factors and combines those to get more weights and one bias because it has its own 4 weights to get the final delivery. The total parameter 25. For click through, each one reveals genuinely different invented factors. Okay, each one reveal differently. You will click through the genuinely. Okay, you will see the different. The core question in to your question, you gave the 4 factors, but the model 4 factors in the final answer. The model insert hidden layer. We can say the pattern layers are raw. a row of new neurons that nobody designed. Each hidden neuron is its own little formula. Take all four inputs, multiply by its own learned weights, add its own bias, and get one number out. What makes this powerful is that each hidden neuron can end up representing a completely different combination of your original factors, and these combinations combine often correspond to real world patterns that exist in the data, even though no human ever told the model to. Okay, so okay, walking through the four example, I showed the clearest one, the weights of the high distance approximately near zero on traffic and the weather. This neuron essentially asks, is this long trip carrying a heavy load? That is brand new concept. Long haul heavy load that doesn't exist in the single number anywhere in the original data. The Okay, yeah, this is the model built it by noticing that when both distance and parcel count are high together, the program behaves differently than whether the one is high alone. Okay, H1 captures a correlation, not just a combination. It weighs weather heavily, but also gives some weight to traffic. Okay, because in the training model bad weather also tend to be high traffic days, people drive more cautiously, accident increases. The model forces that relationship between two inputs into single learned signal. H4 is the inverse detector. Negative beats on everything plus a high bias means it's on by default and switches off as conditions get harder. Effectively, how easy is this delivery signal? Why this happens? The training process, the next lesson. During training, the model starts with random weights for all 20 hidden layer parameters. It makes predictions, compares it to real delivery time, and is wrong. Uh, During training the model with this number 20 parameter, it makes a prediction, compares it to the real delivery time, and is wrong. It then nudges every single weight slightly, including the hidden ones, in the directions in the direction that would have made the prediction more accurate. Repeat this millions of times across millions of deliveries, and the hidden weights settled into configurations like H1, H4, not because anyone designed them to detect rush hour or heavy load, but because those configurations happen to be useful for minimizing error. Why this scales to 1 trillion in real LLM? Each layer has thousands of hidden neurons, and there are 100 layers stacked. Layer 1 hidden neuron might detect simple things, is word a verb. Layer 2 neuron detect is a layer 1's take layer 1's outputs as your inputs and detect more abstract things like, is this sentence sarcastic? By layer 96, the factors being computed are so abstract, combinations. Uh, Layer 96, the factors being computed are so abstract, combination that they don't correspond to single human nameable concept anymore. Yet together, they are what allows the model to write coherent paragraphs. Your 4 input for an exam is the smallest possible version of exactly this mechanism. Okay, got it. Now we made this article, and let me publish it, and hopefully it will be great as well. Okay, so yeah, let me try to have it and we will try to make this thing. Okay, I'm going to publish it and see how the result will be. So see you in the next session hopefully. Thank you guys, bye.